I welcome all the members to day 2 of our faculty development program. Today's session focuses on robot programming basics and syntax using an industrial case study. In this session, we will understand how industrial robots are programmed. Followed by that, we are going to learn the basic fundamentals of robot programming syntax. And finally, we will explore a practical case study from manufacturing industries. Let us begin our learning journey today. So these are our learning outcomes for day 2 faculty development program. By the end of today's session, you will be able to understand the fundamentals of robot programming, ability to learn commonly used programming syntax, write simple programs efficiently, develop intellectual skill to identify the programming errors, and understand how industrial robots execute automated tasks in real manufacturing environments. Let us now go directly to the conceptual introduction of robot programming. So robot programming is the process of providing instructions that enable industrial robots to perform specific tasks automatically. Programming can be carried out online using a teach pendant or offline using simulation program. Proper programming ensures accuracy, repeatability, and improved productivity in industrial automation. Followed by the introduction, let us now discuss the basic components of robot programming. A robot program comprises of several important elements such as variables, instructions, coordinate systems, sensors and effectors, and motion commands. Together, these components define how the robot senses its environment, move accurately according to the information gathered from the sensor, and performs the desired operation safely and efficiently. Next, we shall understand the basic importance of coordinate systems used in robotics. Industrial robots use different coordinate systems to predefine its movement. These include the world coordinate system, base coordinate system, tool coordinate system, joint coordinate system, and user coordinate system. Understanding these coordinate systems is essential for accurate positioning and precise robot motion. Let us now have a simple understanding on robot programming syntax. Here is a sample robot programming syntax illustrated below. Let us see the explanation for each and every motion commands that are used in this simple programming syntax. Robot programming follows a structured syntax similar to conventional programming languages. A typical program begins with initialization, followed by the initialization, defining the path of the robot to the required position, controlling the gripper arm, and finally ends after completing the task. So the correct syntax ensures reliable and error-free robot operation. What are the common motion commands used in robot programming languages? Motion commands control how the robot moves within a workspace. Here are some of the common motion commands that are listed below. Move J represents joint movement of a robot. Move L represents the linear or straight movement of the robot, and move C represents circular path motion. Additional parameters such as speed and acceleration determines how fast and smoothly the robot completes each and every task. Next thing, we shall understand the importance of programming logic in robot operations. Programming logic allows the robot to make decisions during operations. And here are some of the conditional statements like if and else, if and else help the robot to react to the changing conditions. While loop statements such as for and while, these are used for performing the repeated task efficiently. Wait commands synchronize robot actions with sensors and external devices. So what are the common programming languages used in robot? There are different robot manufacturers use different programming languages. Say ABB uses Rapid, Fanuc uses TP programming, KUKA uses KUKA robot language, and Universal Robot use UR script. Although the syntax may differ slightly, but the basic programming concepts remain similar across all industrial robots. Let us now have a sample example for pick and place robot program. This slide represents a sample pick and place robot program. The robot starts from its initial home position, moves to the pick location, closes the gripper to grasp the target object, transport it to the destination, releases the object, and finally returns to the home position. This sequence forms the basis of many industrial automation applications. Let us now have a case study, industrial case study. Let us begin the real industrial case study. Consider an automotive manufacturing plant where the robots transfer the engine components from one conveyor to another conveyor. The main primary objective is to reduce the manual handling, improve productivity, and achieve consistent quality while ensuring worker safety. So, what is the common workflow carried out in pick and place robot operation? The workflow begins with the robot moving to the home position. It then approaches the pick point, grips the component securely, moves it to the destination, releases the component, and returns to the home position. This sequence is repeatedly carried out through the production cycle. So let us now discuss the importance of error detection present in the robot programming operation. Even well-designed robot programs can encounter errors sometimes. Common issues include incorrect coordinate system, collisions, calibration errors, sensor failures, and improper speed settings. These problems can be minimized through simulation, careful testing, and preventive maintenance. What are the common best practices to be adapted in robot programming languages? Every professional, say robot programmers, follow several best practices. They write clear commands, verify all coordinate systems, perform offline simulations before deployment, maintain safety limits, and continuously optimize programs to reduce cycle time and improve efficiency. Next thing, we are going to have an overview on various simulation software packages. Before implementing final robot programs to the shop floor, engineers typically use simulation software such as Robot Studio, Robot EK Solver, Fanuc RoboGuide, and Copalia Sim. These are some of the standard packages available in the market. These tools allow programmers to validate robot path, collision detection, and optimize the programs without interrupting production. Next, what are the common industrial applications where we can utilize the importance of robot programming for repeated monotonous tasks? Robot programming is widely used across various numerous industries, including automotive, manufacturing, electronic assembly, packaging, warehousing, welding, painting, pharmaceuticals, and healthcare. Automation continues to expand as industries seek greater productivity and flexibility. So, what are the various future trends in robot programming? The future of robot programming includes artificial intelligence, digital twins, Industry 5.0, collaborative robots, cloud robotics, and autonomous manufacturing systems. These technologies enable smarter, more adaptive, and human centric industrial automation. Now, it is your turn as a student or a faculty members from various colleges. Your primary duty is to develop a simple robot program for a pick and place operation for a particular use for sorry for the interruption. So let us have this exercise for our clear understanding about the significant importance of pick and place robot program. Whether you are a student or a teacher, a faculty member from a leading reputed colleges, your primary duty is to develop a simple robot program for a pick and place operation, identify the required motion commands used, define the sequence of operation, and discuss the possible programming errors and how you are going to recover those programming errors with the support of your colleagues. So take this space as an exercise. You can do it in your own workplace and try to explore the importance of robot programming. Now we came to the final end of the day 2 session. Today we explored the fundamentals of robot programming, coordinate systems, programming syntax, motion commands, decision logic, industrial programming languages, and a practical case study. These concepts provide a strong foundation for developing efficient industrial robot applications. So with this above information, I thank each and everyone for your active participation. I hope this session has enhanced your understanding of robot programming. I wish you all great success in your learning journey. We will meet in the next upcoming FDP session. Thank you all.